Hello and welcome to our presentation, how BMW and Qualcomm built an automatic driving platform on AWS. I'm really excited to be here at the re:Invent in Las Vegas in front of this great audience. Thank you for joining us today. My name is Jörg Krebs. I'm with BMW and I'm a cloud solution architect. With me on the stage today, there will be Sriram from Qualcomm and Maria from AWS. They will both introduce themselves later on during the course of this presentation. I can imagine a lot of people here in the room dream of having an automated driving car. And of course, you're dreaming of a BMW, right? So let us give you a glimpse how we work on making your dream come true. So let's have a look on the agenda and what we want to cover in today's breakout session. First, we want to give you some context what's behind our next-gen AD platform, answering the questions why we built it up and why we chose AWS. Then in the second part, we want to give you an overview about the platform itself, about the design principles, and also about the building blocks of the platform. In the third part, we will talk about a development journey a typical data engineer has on our platform. And we will show you how we can store and process hundreds of petabytes of data and how even thousands of users can work together on a platform. Finally, we will give you a demo how we visualize the data, and then we will give you some key takeaways. So let's get started. In the first section, let me set the scene and give you some background information. Today at BMW, we already have great premium cars, like the 5 Series you can see here on the left side, and also the 7 Series. In the 5 Series, we already have advanced level 2+ driver assistant functions, like the hands-off option up to 130 kph you can use on the highway. And the 7 Series you can not actually only see here on the slide, but also here at the AWS Expo. So go there and check it out if you haven't yet, but please wait until we are finished. So the level for the 7 Series, we have already announced the level 3 functions to be available at the beginning of next year. Level 3 meaning that really the car is taking over the responsibility instead of the driver. But at BMW, we are actually never satisfied with what we have achieved so far. Therefore, BMW's product range, which has grown successfully now over decades, will be realigned on the basis of the so-called Neue Klasse. So let me present to you the Neue Klasse. Unfortunately, we couldn't bring a car up here on stage, but of course, I have it on a slide. With the BMW Neue Klasse, BMW actually reinvents itself. And it's a perfect play on words that we are now here at the AWS re:Invent. To show you the significance of this initiative, I want to quote our CEO, Oliver Zipse, who said, "The Neue Klasse means nothing less than the future of the BMW brand. It's our totally new generation of cars, which will start in 2025. And on the left side of the screen, you already see the BMW Vision Neue Klasse, as it was presented to the public in Munich at the IAA in September this year. The BMW Neue Klasse combines and will be characterized by 3 key aspects which will dominate the mobility of tomorrow. Those are electrification, digitization, and circularity. It will have a completely new, redefined IT and software architecture." And some of you might now ask, Jörg, at the beginning of your presentation, you had mentioned Qualcomm, so how do they fit into the picture? And actually, they fit in perfectly and are a very essential part. Because to develop this new generation of cars, BMW has partnered with Qualcomm, a top-of-the-class tech company. They bring in the system on a chip. This means the Snapdragon Ride for our ECUs, as well as deep experience in the field of computer vision and computer vision software. We are jointly developing safety features and level 2+ and level 3 functions. And this will even result in a product that Qualcomm can bring to the market again. For the validation and verification of all of those features and functions and the whole system, we actually need to collect a huge amount of data. And this collected data we need to store, process, and then simulate on our platform. This is what Sriram and Maria will tell you in detail in just a few minutes. And maybe some of you have already spotted that there's also another company here on the slides. This is Capgemini, and they are operating and maintaining our platform today. So why did we decide on building an automated driving platform in the cloud? BMW's and Qualcomm's business requirements are based on our learnings we've had on our existing on-prem solutions. From there, we know that we are in a dynamic development process where timelines change and plans get shifted. And we need to be able to adapt to those changes. And so is our IT infrastructure. The IT infrastructure needs to be scalable and flexible to adapt to those changing timelines. And as we are in this agile environment, we of course want to avoid upfront costs and fixed costs. We only want to pay for the storage we use currently and the compute capacity we consume at the moment. Another point was that we collect data all over the world. And we also have development teams from many different companies in many different countries. And therefore, we needed one place where they could work together and collaborate easily. This we found in the cloud. And finally, we wanted to reduce the time to market. So we do that with reusable and well-architected modules, blueprints, and services. With that, we shorten the development cycles and increase the innovative power of our dev teams. So on my last slide, I want to briefly talk about why we chose AWS. Of course, they have a high amount of managed services with a lot of features, but this was only one aspect. Very convincing for us was, during the tender process, the POCs they did. There, they really showed us that they understood our requirements quickly and could already provide well-architected solutions. They brought in their hardcore techies from ProServe. Maria is one of them. And they not only have deep knowledge about their own services, of course, but they also bring in great technical know-how and expertise in the field of ADAS. When the contract was signed, AWS brought together all of their team into one place in Munich. And after aligning the technical architecture and design with us, they started to code like crazy in 2 so-called hackathons. So they were able to build up the platform within 8 weeks when the contract was signed. For that, as I said, they brought in the whole team, coded like crazy, and then setting up this platform so quickly was actually only possible because they had existing reference architectures, frameworks, and blueprints right at their hand. So I explained you the context, what's behind our platform, and now I will hand it over to Sriram, who will give you more details and insights about the platform itself.
Thanks, Jörg. Hi, all. My name is Sriram Palgat. I am Director for Product Management from Qualcomm. And I am responsible for the data and simulation factory and also data-centric AI-related product that run on the cloud. Before I jump in, I just want to get a quick pulse from the audience. How many of you here are from automotive industry? 20, 30%. How many of you here work in ADAS application? Very small percentage. So we want to make sure that we are not just calling out these acronyms, and so we want to make sure that we do justice to that. We will try our best. Yeah. As Jörg mentioned, Qualcomm and BMW are partnering in building an advanced L2 plus L3, level 2 plus level 3 stack, ADAS stack. What does that mean? L3 means actually a driver can take their hands off and they are able to actually, the car drives by itself, right? So it's pretty advanced capability, and that's what we are jointly developing, right? In order to take this kind of an advanced ADAS product to market, we need to make sure that we have a highly sophisticated end-to-end platform on the cloud to enable time to market for these ADAS applications so that developers can innovate quickly and they are able to get the product to the market, right? So the goal for Qualcomm here is also to make sure that whatever we are building for BMW, we are actually we are able to enable BMW to be successful in getting their product out, but also take that product to market, and we are able to actually market that product for other OEMs to take advantage of all the cool capabilities we are building. So what are the key design principles by which we approached in building this product? One of the key principles is reusability. We wanted to make sure that the product is fully reusable, and we actually used all the key blueprints, IAC blueprints and modules to make sure that the product is fully reusable. Not only that, because it is reusable, the developers are able to quickly innovate, and they are able to actually, their time to market is much, much smaller. Also, the other OEMs who will be adopting the product, their time to market is also improved. In addition to reusability, we made sure that it is a highly collaborative platform, meaning there is not only the OEMs, but also the tier one partners and an ecosystem of players come together to make an advanced driver assist system work. So you'll have tier one suppliers, you have partners, you have OEMs, OEM basically the BMW, and they all should be able to actually test their application in a neutral field, and so that all these players work together. For example, I'll give you an example. Qualcomm, for example, is supplying the computer vision stack for this platform. And then the prediction and the drive policy, all the L2 plus and L3 stack, we are jointly developing. That's another stack. And BMW may use a parking product from a tier one OEM. All of these need to be tested effectively in one common ground so that we are able to actually test the whole end-to-end application and we are able to take it to market. Next, we want to make sure that all the different personas who are interacting with this product, like for example, a developer or a realm owner or a test engineer, we want to make sure that their workflow is seamless. And we want to make sure that they have a very, very good UI experience as they are developing this product. Finally, we want to make sure that this product is not just focused on North America or Europe, but also to China and Asia, right? So make sure that it's a global footprint. The product supports a highly scalable global footprint. Now we will get into a little bit more details on how this whole end-to-end product is architected, and also what are all the key feature functions for this product, what are all the key capabilities of this product. So I'm going to talk about a term realm, and we are going to use this a lot in this presentation. First time when I heard our engineering team talk about realm, I thought it's about some sci-fi movie, some Doctor Strange, So it is actually, trust me, it is actually a technical term, and we will talk about more details about it. A realm is a logical group of 4 AWS accounts. It has a CI/CD, development, integration, and production. In addition to that, realm is also a logical bundle of application code and all the associated governance, people, security, roles, budget for each one of these. Because a large pipeline like this, it's actually a massive undertaking, and you can actually go out of control with budgeting, et cetera. So the whole ecosystem needs to be very well set up. And finally, a good example for a realm is when we collect the data from hundreds and hundreds of vehicles, hundreds of petabytes of data, which comes, we have to ingest the data first. That's a realm. And then from there, the data needs to be actually cataloged, and that's another realm. And then from there, the data need to go into an advanced AI testing at scale, hundreds of petabytes of data are tested. That's another realm called reprocessing, like that, so on and so forth. So let's now talk about who are all the different personas. Who are we building this application for? Who is going to use this application? Who's going to take advantage of this platform that is being developed, right? First, the most important persona is the developer who will actually, an ADAS developer. And these are, they are developing advanced AI features. They are doing like, very advanced AI capability. And they should be able to come into the platform and quickly innovate. And they should be able to deploy their application, right? That's an ADAS developer. And so is the case with, and a slightly variation of a developer would be a test engineer. They should be able to actually run nightly CI/CD, a large scale of testing on a nightly basis, and also on a verification and validation at the end, right? So, and then a realm owner. Realm owner is the keeper of the keys for a specific realm. They want to make sure that they define the budget. They want to manage the budget. And they have to actually have the ability to submit requests and get approvals, et cetera. A tenant admin, who's a larger keeper of the keys, basically, they basically keep the keeper of the keys for the overall ecosystem, and they manage the overall budget for that. And finally, a FinOps manager who will actually run all kinds of analytics and data to kind of give the tenant admin to see how each realms are doing. How are we managing our resources, and how are we actually running our pipeline? Now, going a little bit into how we have thoughtfully layered this architecture so that there is a high level of reusability, right? So we start with the basic AWS storage, compute, et cetera, networking, et cetera. And then on top of that, we leverage some of the AWS open source capabilities like ADF. Basically, that has the whole CI/CD capability built into it, et cetera, and some additional capability from their autonomous driving open source bundle, where we use, for example, high-speed data streaming using their Kinesis Firehose, et cetera, right? And then on top of that, we have an horizontal layer which goes like network connectivity, billing functions, security framework, logging and monitoring. These are some of the common capabilities which is used by all the realms. And then on top of that, all of the independent realms layer on top, like our labeling framework, our analytics framework, our reprocessing framework, our KPI and analytics framework, et cetera. All of them, they kind of layer on top. And then on the other side, the personas, the different user community, they actually effectively interact with these realms and the self-service UI to actually get through their day-to-day of their workflow, right? I mean, so it is a very seamlessly architected and leveraged a lot of underlying capabilities from AWS. Now you've understood how we have layered and architected. I want to dig a little deeper into what these product capabilities are. What are we building, right? So imagine there are vehicles which go out from multiple countries, several hundred thousand kilometers of data we gather. What do we do with that data? That data comes into a pipeline. We ingest that data into AWS. And then from there, we actually make sure that the data pipeline, we actually do some pre-processing of the data. What do we do there? We actually go ahead and catalog the data. We go ahead and glean some metadata, and we will actually do some enrichment using advanced AI techniques. We actually enrich the data. Why do we need to do all that? So that a developer is able to easily identify data. For example, if a developer is working on the car's interaction with a bike, for example, they want to make sure that they should be able to quickly put together a data set of bikes. And they should be able to quickly run a model and test their models. And doing the pre-processing and some of the data enrichment and get me all the data where there is a rain or a fog, et cetera, right? They are able to actually quickly put together a data set, curate a data set, and they are able to run these advanced model on top of that. And then we take the data and we send it to labeling pipeline. We also do some automated labeling, again, using some advanced AI techniques. And then an advanced simulation framework and where you are able to plug and play all of the different stacks, like the parking stack I talked about, the CV stack, and for example, the dry policy stack. All of that you are able to simulate at scale. All of these are done at scale. And finally, the verification and validation framework, that's when all of these are orchestrated together and you run it at scale. Like, for example, before releasing a product, you want to make sure that all the data we collected from all the countries, and the product is working seamlessly. So that's where the verification and validation pipeline, which take advantage of all the other framework and actually execute a large amount of testing at scale. And finally, where do we analyze the results of these tests, right? That's where we used an advanced analytics and visualization capability, where actually a developer will be able to drill down into one specific failure, and from there, actually be able to identify which data, what pipeline, so very quickly get access to all the different. In fact, Maria will show a quick demo of that as well. So this gives an idea of the whole end-to-end pipeline and the massiveness of this pipeline and how we leverage AWS underneath the covers. With that, I'm going to quickly when we are doing this reprocessing of this high volume of data, recently I'm very happy to share that our Qualcomm AI100 accelerators are now available on AWS for us to actually run advanced AI models. Important thing to note here is this AI accelerator is not only for an ADAS application. Of course, we will be leveraging it heavily for ADAS application, but also for any generative AI or any other capabilities. This EC2 instance actually is capable to handle. So you can scan the QR code to get more details about that. And what we are going to do is quickly show you a demo. Again, our goal is to give you a tip of the iceberg. I mean, this is a very massive platform. So we won't be able to show all the capabilities, but just to see how a developer's workflow or an end-to-end developer workflow would look like, right? That's our goal. So what we are going to show you is 4 different bundles. One, realm owner is going to request for a realm, saying that, OK, I'm going to do a data landing zone realm or a reprocessing realm. And then a realm admin is going to approve that realm. And what they are going to do is they say, OK, the budget looks OK. We are still within the overall budget. I'm going to approve that. And then the realm owner is going to jump back again and say, OK, now my realm is approved. I'm going to actually now go ahead and add users to that realm. A developer user gets added. And a developer user now what he's going to do is, he or she is going to do, jump in and start running a high-end reprocessing graph on our DLQ instance, on our AI100 instance. And then after that, there will be some KPIs and analytics. So that's the overall flow for the demo. And I will quickly give commentary as we go through, but that's the demo. So here's when realm owner actually logging in and saying that, OK, hey, we need to create a realm. Here, that particular user is creating a landing zone realm and submitting the request. And then a realm admin, she looks at the request, and she says, OK, now I'm going to 2500 sounds OK. I'm going to approve the request. And once the realm is approved, create is initiated. And you can see 4 different, the CI/CD, integration, production, all the different environments are created. And after the environment is created, now you are able to, it's quickly set up, right? I mean, it's all very seamless workflow. And then what they do is, OK, I want to go into this realm, and I want to go ahead and add users to the realm. They go ahead and create multiple users who will be using that realm, a developer or a tester, test engineer, et cetera, right? These roles get developed. Now a developer logs in. now finds an Qualcomm AI100 instance where the developer is going to actually submit a very complex graph, like a model graph. And they pick the AI100 instance, and they actually submit the graph. And the graph actually goes through complex execution, several different instances, a CPU instance, a GPU instance, DLQ, AI100 instance. They are all orchestrated using this complex graph to actually execute a very complex AI model. And once the graph gets executed, they are able to actually see the metrics and analytics, et cetera. Here is a quick demo of all the KPIs and metrics. For example, if you're running an ingest pipeline, you want to make sure that what's the throughput, how much data is stored, what is the ingress and egress of my pipeline. Like that, there is analytics and there is KPIs for every single realm. Every single realm will have their own KPIs and analytics. All of that is already set up. Here, they are looking at the data zone, looking at how much data has passed through the pipeline, looking at some of the jobs, which jobs are successfully completed, which jobs are still running, et cetera. And finally, we'll also show you an FinOps analytics capability where a FinOps analyst is able to see what kind of money is being spent and which particular realm is over on budget, which realm is doing okay on budget, et cetera. You can see that it is a very comprehensive end-to-end ecosystem. And that's a quick glimpse of what this product is capability. Now now you have understood what the product capability is, now we are going to drill down a little bit deeper into the AWS architecture, how this whole end-to-end product is architected. For that, I transition to Maria.
Hi, everyone. My name is Maria. I am a big data architect from Professional Services, AWS, and I was part of the team that designed and developed this platform. From the beginning of the project, I focused on developing everything that revolves around the realms, which are the building blocks of the platform. So now, let's put ourselves in the shoes of an ADAS engineer that is using the platform to develop these AV ADAS features. And let's take a look how this development journey looks end to end. Before getting into the technical details, I want to talk about data, because without data, it wouldn't be possible to develop these ADAS functionalities. So to develop these features, thousands and thousands of kilometers are driven worldwide to try to capture as many traffic situations as possible. This information is being captured with specific sensors such as LiDARs, cameras, and radars. These sensors are connected all together into a device in the car that is called logger, which is storing all these informations of the data feeds. Once the memory of the logger is full with data, then it is extracted from the car and plugged into the copy stations. Copy stations are physical locations designed for high-efficiency data upload, and they are connected to the cloud via Direct Connect. From this moment on is when the data from the sensors and the signals starts coming into the platform. The data is uploaded into a specific realm that is called landing zone. Landing zone acts as a gateway between the rest of the realms in the platform and the physical world. Once the data is successfully and completely uploaded into landing zone, then this realm would communicate with the rest of the platform saying, hey, new disk is available to be further processed. Then different realms at different times in an asynchronously fashion would interact with this data. Among different realms that we have in the platform, I want to highlight, for example, ingest, which is taking care of extracting all the sessions in the disk, moving all those sessions to collected zone, which is the permanent stored realm, and it's also extracting metadata of this process. And of course, making this information available for the rest of the realms. Other realm that we have in the platform is labeling. Labeling is selecting, extracting, and adding labels on top of this data to then making this information available for the rest of the realms. So now, let's remember we are ADAS engineers, so you might be wondering, okay, this is a high-level overview, but how do we actually start developing our realms? Let's take a look. So to develop a realm, we need two main things in place. In one hand, you need the business logic, so the ADAS applications that are running in your realm. In the other hand, you need the infrastructure, so the AWS services that support these ADAS applications. For the first thing, for the business logic, the platform provides Artifact Store. Artifact Store is a centralized account that all the realms have access by default. And the particularity of this Artifact Store is this IAM user that we see there. Let's assume that we, ADAS engineers, we already have our pipelines that are taking care of building the ADAS applications. So you don't want to spend time migrating your pipeline or creating a pipeline new for the setup. What you can do is you can take this IAM user and plug it into your pipelines. And then, thanks to this IAM user, your pipelines will be authorized to push these artifacts. Also, by artifacts, I mean everything that is around scripts, config files, and Docker images. Moving on to the CI/CD and the infrastructure, the realm automatically, when you request it, comes with a CI/CD setup, which is ready to use with little to no configuration effort. This setup is located in the CI/CD account and is composed of three main services. These are, first, code commit, which contains an initialized infrastructure as code application where the services of the realms are defined. Then, this code commit repository has three branches, dev, int, and prod, which have a corresponding code pipeline connected to it. Code pipeline is a continuous delivery service that is designed for automating the release of changes into a code repo. In each of these pipelines, there's always a build step where the code is compiled and remotely from the CI/CD, it is deployed into the specific corresponding development environment. If the change was made into the dev branch, then these changes will be deployed into the dev account, int to int, and prod to prod. So when we request a new realm, the onboarding process is super simple with this setup. The only thing that we need to do is log into the CI/CD console, go to the code commit repository, clone it locally, and reference our artifacts that we pushed into Artifact Store. Once we pushed all these changes into code commit, then the setup will take care of pulling the artifacts and deploying everything together with the infrastructure in the corresponding development environments. So the main idea here to have in mind is the onboarding process to a newly provisioned realm is as effortless as possible. Because, in one hand, you don't need to spend time migrating your existing pipelines that are taking care of your business logic thanks to this IAM user. And on the other hand, you don't need to build a CI/CD setup because that's already provisioned out of the box by the platform. So, moving on to the second phase, remember we are ADAS engineers and we are developing a realm. So now, let's assume that we successfully onboarded into our realm. We have our cloned repository locally, and we want to start actively developing. What are some key things that the platform offers which accelerates development of the developers? In here, I want to introduce the concept of blueprints. Blueprints are infrastructure as code templates that contain pre-composed realm logic. Each realm type in the platform has a corresponding blueprint to it, which defines the baseline resources that get automatically deployed on provisioning time. For example, Sriram was talking about reprocessing realm. So the blueprint template that corresponds to the reprocessing realm has, among other services, the configuration necessary to deploy the EC2 instance that contain the Qualcomm chip AI100. So what happens when someone requests a new realm with as a service UI that Sriram showed is there's a lot of fields that you need to fill up, but one of them is the realm type. So when you select the realm type, what happens under the hood is that the account provisioning framework would select the specific blueprint that corresponds to that realm type. Then it will transform it into the code commit repo that we saw earlier. So what is nice to know is you are not limited by what was defined in the blueprint. Once the blueprint is transformed into the code commit repository, you can customize it or add as many services as you would like. So the blueprint is only a baseline, a starter for you. Even one step further, if, let's say, you added some customizations that you think they bring added value to the platform, you can even publish back a new version to the blueprint in the platform. And in that regard, if someone else is requesting in the future the same realm that you developed, they can select between different versions. So the second thing that the platform offers, which accelerates development, is infrastructure as code modules. This is a collection of modules that are accessible to all the realms, and all the realms have access to them by default, so no configuration needed. The idea behind it is we want you to provide infrastructure as code modules which implement common ADAS tasks. And then we, the engineers, we can use these modules to customize our realm and add the services on top of the baseline. These infrastructure as code modules, together with the blueprints, everything is based with ADDF. ADDF, or Autonomous Driving Data Framework, is an open source project that we, from Professional Services, developed to try to come up with reusable and modular infrastructure as code artifacts which implement common ADAS tasks. Some examples of modules that we have in the platform are the compute group, within which we have, if we want to, for example, deploy a containerized pipeline, we can use the batch module to deploy a batch compute environment. Or if you want to use Kubernetes, there's an ingest module available, ready to use and deploy. Or if we have some Spark applications, we can also use the EMR module. Another group that we have of modules is the orchestration modules. I'm going to be explaining much more in detail into the next slides, but essentially they allow the realms to communicate with the rest of the realms in the platform in a standardized way. We even have more complex examples of how to wire different services together to achieve a common ADAS task, such as a signal extraction pipeline. So the key message here is the platform offers a series of infrastructure as code artifacts which help us, ADAS engineers, to make the infrastructure development as easy and as reusable as possible. So we can focus in what we know best, which is the ADAS development. All right, so moving on to the third and final phase of our realm development. Now, let's assume we are done with our infrastructure, we are done with our business logic, and now we want to plug our realm into the mesh of realms in the platform. So the realms in the platform communicate in an event-driven, standardized pub-sub communication model. For this to work, there's two key things that need to be in place. On one hand, we have overarching orchestration. Overarching orchestration is a realm, as any other, but that does some specific capabilities. By means of AppSync and Dynamo, overarching orchestration provides an interface to the rest of the realms to be able to define to which specific events they want to be subscribed. By means of Lambda and EventBridge, the overarching orchestration is able to receive all the events being published from the realms and forward those events to the target realms. Then, moving on to the realms themselves, to be able to communicate using this setup, they need to do two things. First, the realms need to define to which specific events they want to be subscribed to, using this interface that overarching orchestration provides. They can do so by doing API calls of the AppSync API of overarching orchestration. The second thing that needs to happen inside the realms is that they need to have the orchestration modules deployed inside the realms. This is the event writer and event listener. These two modules allow the realms to publish events from the REM to overarching orchestration and received events from overarching orchestration to the REMs. So let's take a look into an example of 4 REMs communicating using this setup. Here we have landing zone, ingest, data quality, and signal extractions. As we know, landing zone is the REM where the data is uploaded in the first instance. So as soon as the data is successfully and completely uploaded in landing zone, then landing zone would set an event to overarching orchestration saying, hey, disk is uploaded. Then overarching orchestration knows that ingest is subscribed to that event, and therefore it will forward this event to the REM. Once ingest receives this event, this will trigger internal processes inside ingest, which will result in some events being published back into overarching orchestration. This is session ingested and text requested. Then, data quality is subscribed to this event that was published by ingest. And so overarching orchestration would forward this event. Then data quality would trigger some internal processes and eventually would publish back an event to overarching orchestration. This is text succeeded. Last but not least, signal extraction is subscribed to 2 events coming from 2 different REMs. Session ingested from ingest and text succeeded from data quality. This will be received asynchronously as soon as they are fired from the original REMs. Then signal extraction will trigger some workloads inside the REM, and then finally will publish back an event to overarching orchestration, saying, hey, signals well extracted. As you can see, the events in the platform are communicated in a standardized, event-driven, and pub-sub communication model. The key thing here is this setup allows and accommodates the flexibility that all the REMs need in order to meet the requirements in the order to communicate. From REMs that are pure publishers, like landing zone, from REMs that are subscribed to multiple events, and all the different use cases in between. This setup accommodates them all. All right. So moving on to the last piece of information that we want to talk about regarding REMs is data visualization. So we wanted to showcase one of the features of the many REMs that we had, and we chose data visualization because we find it pretty interesting and easy to see. For that, here I want to present the data view REM. This data view REM essentially allows the ADAS engineers to actually help ADAS engineers by visualizing different sensors and signals from the car, together with some computer vision and object detection processing. The way this works is there's an EC2 instance running in the REM that has some software pre-installed in it. In one hand, it has NiceTCV, which allows a remote desktop connection to the instance. So that's what we are seeing right now. Then, in the other hand, there's Foxglove Studio. This software allows to establish a connection between the EC2 instance and a Rostbridge service that is running in EKS or ECS. This Rostbridge service is the one that is in charge of fetching the information of the signals and sensors and streaming that back to the instance via web sockets. Let's see this in action. Here, we are opening a window of Foxglove Studio, and we are establishing a new connection to a Rostbridge service. To do that, we need to provide the URL of the application load balancer that is fronting the service. Once we establish a connection, we can see the different visualization panels. Starting from the upper right, we see the LiDAR, followed by the outside vehicle camera, and followed by the geolocation information of the odometry signal of the ECU. On the bottom right, we see the results of the object detection processing. We can see that the object detection is classifying different objects in the road. We can see that there's the different lanes, the trucks, the cars, and also some signals by the road. What is also really nice is that the software allows to explore the 3 dimensions of the signals that allow them, such as the visualization of the LiDAR. We can also play back and forth to the different signals and be able to see everything together in a synchronized way. So that was a little teaser for how we visualize data with the platform. Let's wrap the session with some key takeaways. So the next-gen AD platform provides a self-service UI that allows different personas to interact and manage the lifecycle of ADAS applications. From requesting a REM to giving access to developers to monitoring costs, everything is done through the self-service UI. Also, everything that you saw, from the features of the platform to the infrastructure as code of the REMs, everything is defined with infrastructure as code, and therefore is portable and can be easily reused and rolled out to other ADAS projects. The platform also offloads the undifferentiated heavy lifting of having to configure yourselves things such as the networking, the security, the CI/CD setup. All these features are automatically provisioned by default thanks to the platform. Also, this platform accelerates development, and it does so by providing infrastructure as code modules, which make the life of the developers easier, and they can focus on what they know best, which is the ADAS feature development. Last but not least, the platform offers flexibility, which is required by the REMs to be able to meet the communication requirements. The REMs are communicating in an event-driven, PubSub, and standardized way. All right, so that's all we have prepared for today. Thank you very much for being here. We would really appreciate if you could complete the session survey. Feedback is always more than welcome.